Alright, so today we're going to do 5-6. We're doing 5-6 after 6-2. It kind of leads into 6-3. So our objectives for today, the student will be able to explore inverse functions and find and verify inverses of nonlinear functions. So, first thing we're going to look at is writing a formula for the input of a function. So now, instead of y equals like 3x plus 4, now we're going to change it and write the formula in terms of x. So our steps, step 1, simply solve y equals f of x, whatever the function is for x. So you're going to get x by itself. Then plug in the value that they give you for y and solve for x. So this should be fairly easy for you. So it gives us an example 1. It says let f of x equal 2x plus 3, solve for x, and then find the input when y is equal to negative 7. So again, remember our f of x is the same as y. So we're going to take this function, y equals 2x plus 3, and we're going to solve for x. So we would subtract 3, and then divide by 2. And so we get y minus 3 divided by 2 equals x. And now we're simply going to plug in negative 7 for y. So negative 7 minus 3 is a negative 10 divided by 2. And so our x in this case is equal to negative 5. So that's all you have to do on those. So hopefully you'll find that fairly easy. So I would like you to try these 3. So just pause the video, try it, then come back and check and see how you did. So again, solve for x, add 2, and then we're going to plug 2 in for the output, which is our y value. So 2 plus 2 equals x, and so in this case, x equals 4. We do this one. A little bit more difficult, divide by 2. Now we got to get x by itself, so now we take the square root of both sides. So we get the square root of y divided by 2 equals x. And now we plug in 2. 2 divided by 2 is 1. And so the square root of 1 is 1. Technically plus or minus. So x equals plus or minus 1. If you check it, you can plug it in here. 1 squared is 1 times 2 is 2 equals 2. And negative 1 squared is 1 times 2 is 2. So it checks. And so the last one, y equals negative x cubed plus 3. So you should have subtracted 3. I'm going to get rid of the negative sign by multiplying everything by a negative 1. And so we get negative y plus 3 equals x cubed. And then we take the cube root of both sides. And so we get the cube root of negative y plus 3 equals x. And so now you plug in 2. Negative 2 plus 3 is 1. The cube root of 1 is 1. Again, since it's a cube root, that takes care of whether it's positive or negative. It's just one value. And so in this case, 1 would equal x. Again, you can check it. 1 cubed would be 1. The opposite of 1 is negative 1 plus 3 is 2. And so it checks. So hopefully you found those fairly easy to do. So inverse functions. Inverse functions, we've worked with this a lot really from when you first started doing algebra. The inverse of multiplication is division, the inverse of addition is subtraction. Those are operations that cancel each other out. And so as you look at an inverse function is simply functions that undo each other, so they cancel each other out. If you take the money you have and you times it by 5 and then you divide it by 5, you end up back where you started with. Same thing if you add 10 to something, but then you subtract 10 from that quantity, you end up back where you started. So as we look at this, If you have a chart, it's really easy. You simply switch the x and y values. So if this was our function here, f of x, negative 2, negative 1, 0, 1, and 2, and you get 3, 5, 7, 9, 11, all you do for your inverse, and the inverse function is written with a negative 1 power. So the inverse of that would simply be, you take your y values would all come up and be your x values, and your x values would all come down and be your y values matched up with each other. So it's pretty easy if you have a chart. If you have a f of x equals, where you just have an equation or a function, then there are two ways to find the inverse. Method 1 is use inverse operations in reverse order. Now, the second method is a little bit easier, but you have to use this method when you do story problems a lot because the values can't be switched. You can't switch the values of people with the values of money and things like that. So you'll see as we go through this. So the first method is use the inverse operations and in reverse order. So if I was to look at this function, this would tell me first I would multiply by 3, then I would subtract 1. So I've got multiply by 3 and then subtract 1. So to do that in reverse with inverse operations, the last thing we do is subtract 1, so we do the inverse of that, we would add 1, so we would take x plus 1, and then we would divide by 3. And that would give us the inverse, which they're calling g of x, and this is the inverse function. So that's method 1. Method 2 is you simply switch the x and y values, so we're going to do the same function. Remember, this is f of x is the same as y, so y equals 3x minus 1. So the first thing we do is we switch the x and y values. So we just come here and we go x equals 3y minus 1. And then, secondly, we solve for y. So if I was to solve for y, I would add 1 and then divide by 3. And that would be our g of x for the inverse function. So you can see we get the same thing either way. It's just a lot of times, especially as you get into more complicated problems, it's kind of hard to go through and reverse all the possible functions, operations you could have. So you can do this whichever way you want, but I would like you to try these 3 problems using whichever method you would want, and I'll go back through and you can check and say you did. And I'll probably just reverse them, or switch the x and y and solve, but you can do it either way. So go ahead and pause the video and try these 3. So, y equals 2x, switch the x and y, divide by 2, and we get x over 2, which on these we're just going to put it as g of x, as the inverse function. This one, y equals negative x plus 1, switch the x and y. Now you keep the sign with where it's at, you don't move the negative sign, so it becomes x equals negative y plus 1. So we would subtract 1 and get x minus 1 equals negative y, and then multiply by a negative 1 to get rid of that negative 1, or divide by it, doesn't make any difference. And you get negative x plus 1 equals our g of x for the inverse function. And then last one, you should have had y equals 1/3 x minus 2. Switch the x and y. So we would first of all add 2. And then to remember, it's multiplied by 1/3, so you divide by 1/3, but remember, multiply by the reciprocal. So I'm going to multiply this side by 3. Remember, you multiply the whole thing by 3, so you distribute that, and you should have gotten 3x plus 6 equals our inverse function, g of x. So hopefully that makes sense. Again, you can switch the operations, so if you were doing this, since it's multiplied, the first thing you would do is divide. You take your x and you divide by 2, since it was multiplied. Here, if you want to do reverse operations, you take your x, you multiply by negative 1, then add 1, so the inverse would be subtract 1, and then divide by negative 1, which would give you the negative x plus 1. And this one, again, you would take the x, and instead of subtracting 2, you would add 2, and then multiply by 3, and you get 3x plus 6. So that shows it to you using either method. You can see you get the same thing, it just depends on what you're more comfortable doing. But again, as you get to more complicated ones, it's a little easier to switch the x and y, and then solve for y. So next, this example, find the inverse of the function x squared. When x is greater than 0, then graph the function and its inverse. Now, I'm not going to have you graph, but I want to show you how you could graph if you had to. So this is y equals x squared, but we're only doing it for when x is greater than 0. Okay, so that would be, we could plug in values, but we're going to go ahead and find the inverse, so I'm going to switch the x and y. And so you would take the square root. So it would be plus or minus, but remember, we're only doing it for x is greater than 0, so we need to worry about that. But we found the inverse. This is our g of x. If I was to graph it, all I'd have to do is make a table. So my x values, again, we're only doing when x is greater than 0, so I'm going to start at 1. So if I was to plug that in, 1 squared would be 1, 4, 9, 16. Well, remember, if I wanted to graph the inverse, I just switch the x and y values. So it would be 1, 4, 9, and 16. And so I would be at 1, 2, 3, and 4 for y. So if we were to look at that graph, the graph of the function at 1, let's do this in red. So at 1, I'm at 1. At 0, it would be an open circle. We can't be there. 0 would be 0. But 1, 2, I would be at 4. 3, I'd be at 9, and so on. So it would look something like this. It'd just be that half of the parabola for x squared. And now as we take the inverse of that, at 1, I would be at 1 still. At 0, I would be at 0. But again, that would be an open circle. But at 4, I would be at 2. And at 9, I'd be at 3. And so you can see it would look like this. Okay? So it'd be easy to if you were to graph these, all you have to do is make a table and switch the x and y values. And again, I'm going to assume that we can plot points, so I'm not going to have you do that. So, next thing, to determine if an inverse is a function, use the horizontal line test on the original function. If you go back to your Algebra 1 days, you should have learned, and we may have talked about it earlier this year, I can't remember. But either way, to tell if something is a function, you can do what's called a vertical line test. And so that would be if I have a graph and I do a vertical line test anywhere along here, as long as I only cross the graph in one place, then it's a function. Where it's not a function, if you remember, is if you get two values in the same point. So like if I take a circle's not a function because I will cross the graph at more than one place with a vertical line. Okay? Well, to determine if the inverse is a function, because remember that's a reverse, it's going to flip the graph. Now what we use is what's called a horizontal line test. So if we do a horizontal line test, if it crosses the graph at more than one place, then it's not a function, the inverse. So like on this, if I was to take this line, it's going to, since it goes forever, it's going to cross the graph multiple times sometimes. And so the inverse of this would not be a function. Again, with a circle, again, it's going to cross on this horizontal line test more than once. So all you have to do to determine if the inverse is a function, if they give you the graph, is do the horizontal line test. If it crosses in more than one place, then it's not a function. So if I gave you this horizontal, that would be a function. It only crosses at one point every single time. Again, this one would be not a function, function, and this one would not be not a function because it crosses more than once. So, if any horizontal line crosses a graph in only one place, then the inverse is a function. If any horizontal line crosses a graph in more than one place, then the inverse is not a function. So we're going to look now at the examples 4 and 5 on page 279 in the textbook. So it says, consider the function f of x is 2 to the x plus 3 plus 1. Determine whether the inverse of the function is a function. So that's where we do the horizontal line test. And if we do this, it does not cross. Now it's a little bit hard to tell, but again, it's not going down. It just flattens out really low here. But we're going to say this does not cross. It says, notice that no horizontal line intersects the graph more than once. It's hard because lines have thickness and it looks like it flattens out here. But it's coming up and touching 0 and then it's slowly climbing. It's just very little increase here and very little increase here, so it kind of looks like it's flattening out, but it's not. So that would be a function. And then you just go through and you do the switch x and y, so they did that here. They moved the y over here and the x over here, and then they solved for y, and they got the cube root of x minus 1 divided by 2. So the inverse, g of x, is the cube root of x minus 1 divided by 2. So that part's the same as what we did before. If we look at example 5, it says, consider the function f of x equals 2 times the square root of x minus 3. Determine whether the function, the inverse of f is a function, then find its inverse. So again, we would do the horizontal line test. So according to this, it would never cross more than once, so the inverse would be a function. And then again, just like we did before, you switch the x and the y. So now in this case, I wouldn't have done it this way. They squared the whole thing first. I would have divided by 2 first and then squared it, but either way you're going to get the same thing. It's just written a little differently. So if you would have gotten rid of the 2 first, x divided by 2 equals the square root of y minus 3, then squared it, you would have gotten x squared over 4 equals y minus 3, and then added 3, you would have gotten this. As you can see, it's really the same thing as we've got here. So it's really up to you how you do this. I just like to get the square root, the radical parts by themselves before I start squaring both sides, but it's fine to do it this way. The only thing you have to be careful of is if this was a like 2 plus and you did that, then you would have to FOIL that and it gets really complicated. So I would get in the habit of getting the square root or radical by itself first and not doing it the way the textbook did it there. So I would like you now to try 7, 8, and 9. Find the inverse of the function, then graph its function again. I don't want you to graph the function its inverse. That's just a process of plotting in points and doing it. What I'd like you to do, though, is to find the inverses of these. And so go ahead, pause the video, come back, and then see how you did on that. So as we do this one, again, this is y equals negative x squared. Now we're only working about x less than or equal to 0. And so on this, again, we're going to switch the x and y. So x equals negative y squared. So this gives us negative x equals y squared. And so when we take the square root, we get the square root of negative x equals y. Now, the reason, now this would technically be plus or minus. This is the reason they put x is less than or equal to 0, because That way that's a negative, which makes this positive in here, so we can take the square root of it. If x was greater than 0, we'd have negative and you'd have imaginary numbers. So that's why they made the restriction on that. This one, y equals negative x cubed plus 4. So again, we would subtract 4. Get rid of the negative sign, change the sign of everything. And then take the cube root. So you should have gotten cube root of y, negative y plus 4 equals, didn't switch the x and y. So we switched the x and y. So we get x equals negative y cubed plus 4. Subtract the 4. X minus 4 equal negative y cubed. Take the negative sign, multiply or divide everything by negative, so negative x plus 4 equals y cubed, and then take the cube root of everything. So I'm just going to put that up here. Cube root of negative x plus 4 is equal to y. And then lastly, f of x equals the square root of x plus 2. So this is y equals the square root of x plus 2. Switch the x and y. Square both sides. And then subtract 2. So we get x squared minus 2 equals our, and again on all of these should be g of x because it's the inverse. So at the end we'll just change it to g of x. So remember to do that. So, last thing, f and g are inverse functions if f of g of x equals x and g of f of x equals x. So again, this is where it comes into that they cancel each other out. Remember, if this is the amount of money you have on you right now, and we times that by 3, the inverse of that would be divide that by 3, and that would cancel back out and get us to our original amount, in this case a value we don't know of x. So anytime you plug g of x into f, you should get x, and f of x into g, you should get x. So we can determine when they give us two functions whether they're inverses or not. So they gave us this, f of x is equal to 3x minus 1, and g of x is equal to x plus 1 over 3. So all you do on these is you plug g of x in for x. So I'm going to go 3, and then I replace x with the inverse, x plus 1 divided by 3 minus 1. And I simplify that. So here the 3's would cancel, and I get x plus 1 minus 1 minus 1. Which equals x. And so it's an inverse that way, now we have to check it the other way. So now we take this and plug it in for x. So replace the x with 3x minus 1 plus 1 and then divide by 3. Well, we simplify the top first. Minus 1 plus 1 is 3x. And 3x divided by 3, the 3's cancel, and we get x. And so those would be inverse functions of each other. So they're going to ask you, they're going to give you two functions and ask you to determine if they're inverses or not. So, as an example, if we look at 10, here it says x plus 5 and g of x is x minus 5, so we just plug it in. So we're going to take this and plug it in for x. So go ahead and try this. And then come back and check it. Same thing here. You're going to take this and plug it in for x and work it out. And then you're going to do it the other way also. Make sure it works both ways. So go ahead and pause the video and try that. Come back, see how it worked. So if we try the first one, you should have gotten, we're going to replace the x with x minus 5. Plus 5, the 5's cancel, so we get x. So that would work that way. Now we try it the other way. We replace this with x. So x plus 5. Minus 5 also gives us x, so the answer would be yes. If we do this one, we're going to replace the x with this, so we get 8 and then we're going to replace the x with the cube root of 2x, and then we're going to cube it, because we have that cube there. Remember, we just took this and plugged it in for x, so we still have that cube. Well, the cube and the cube root cancel, so we get 8 times 2x, which equals 16x. And you don't have to try it the other way. If it doesn't work one way, the answer is no. And so those would not be inverse functions. So, let's look at example number 7 on page 280. Because this is where we get into, so let's go through when you're solving real life problems, so story problems. In many real life problems, formulas contain meaningful variables such as the radius r in the formula for the surface area S of a sphere, where surface area equals 4 pi r squared. In this situation, switching the variables to find the inverse would cause confusion by switching the meanings of S, which is the surface area, and the r, which is radius, because those two things don't represent the same values like they do with the x and the y with numbers. And so we can't just, so when finding the inverses, solve for r without switching the variables. So instead of doing this now, to find the inverse, what we're going to do is we're just going to simply solve for r when you have a story problem. So the example they give here is s equals 4 pi r squared, so they divided by 4 pi. To get r squared, then they took the square root, and so we can now find r by using the square root of the surface area divided by 4 pi. And so now it says find the radius of the sphere when the surface area is 100 pi. So now we just plug in that 100 pi for the surface area in the formula. So they plugged it in here, 100 pi, 100, the pi's cancel, 100 divided by 4 is 25, so we square 25. Now again, that would be plus or minus 5, but we're talking about radius, so it has to be positive length. So it's a positive 5. So on story problems, you have to make sure to go ahead and just solve for the variable you're looking for, and then plug in the value. And so that completes 5-6. And so your assignment on this is page 281, numbers 5 to 21, the odds. Also number 22, and then 23 to 37, the odds, and then 49 and 51. Remember, you don't need to graph these. Again, I'm going to assume that you could plug the values in and switch the x's and y's and plot the points. So, good luck on this.